inclusion of integral actions is slightly different from your proper and strictly proper, because it's simply improper for this case. Alright, and therefore you have a slightly different criteria. Alright, previously for strictly proper, your g of s is actually m minus 1, and then your h prime s is actually, your hs is actually 1. Now the difference between our improper and strictly proper is this thing. You have a s prime, g prime gs over h prime s times s. Alright, so you have an integrator over here. Alright, that's the reason behind the integral action. And since we know that you're gonna design your controller to suit your plant, alright, therefore this s somewhat makes you feel a bit troublesome, and therefore I remove this 1 over s and I simply multiply to your plant first, just for nice. Alright, so therefore what I have, my first step is to multiply 1 over s to your plant. Okay, so therefore this is just this meaning of that. Okay, the second step now, once you remove your 1 over s, you should have c prime. Right, instead of c, it's c prime now. So to an intuitive example, or I'm not going to derive to you because it's not very clear in the derivation part, is if for example you take this as dy dt, okay, and the 1 over s is the integration, because it's an integrating term if you still remember. Alright, whereas is equals to maybe we call this ct. Alright, or maybe I just call it yt lah, okay, yt. And then if you were to remove your 1 over s now, you remove it. So this means that I'm going to remove my integration. Right, so I didn't integrate anymore. So therefore instead of yt, which is at first was this one, now it will become y dot t, because it's simply dy dt is a differentiation, or in other words we call this y prime. And this explains why when we remove the 1 over s, we're going to add in the c prime over here. Alright, so I hope that this is pretty clear for you, although I didn't explicitly derive the actual form, but at least you see some link in there right now. Alright, but let's carry on first and see how things are varies, but at least it's kind of straightforward also. So the next step what we can do is to find our plant's transfer function, if you still remember. Alright, this is very important, and therefore the transfer function is this thing. Alright, so your b naught s is equals to 3, and your a naught s is equals to s plus 1, s plus 3. Alright, and the degree of the order of degree for this 3 is what? It's just simply 0 lah. Alright, and the degree of this a of s is actually 2. Okay, you may ask me, why didn't I include this s also? Why didn't I include over here? Because we just temporarily put it over there, so we just somewhat ignore this first. Alright, ignore this first, don't care him first. So our highest degree is actually 2, and therefore is equals to n, and therefore this is our third step. So far so good. And therefore the next step for us to do is to set up a transfer function for a general transfer function for our controller. If you still remember this thing over here. Alright, so what we can do is to use our criteria now. This is the improper criteria. Alright, so I'll just sub in n, which is equals to 2, to here. So 2 minus 1 is equals to 1. Alright, while your n over here equals to 2 is to sub in as your degree for your g of s. Alright, is equals to so it's equals to 2 lah. Alright, so your g of s over here is 2 degree, and therefore it's just simply g1 s square plus, this should be g2 and g1 s plus g0. Alright, don't be scared by this g2 or g1 if you still remember these are some numbers, maybe 5s squared plus 4s plus 3. Alright, but because we want some general equation, so therefore we replace this 5 as this g2 first. We don't know what is this value also ma. Right, so we just simply write in terms of a general equation. Alright, just to remind you about that. Divided by this thing over here, h prime s, alright, is an order of degree 1. please reminded that h prime s, alright, therefore you are talking about m minus 1 in this case, alright, it is improper. But take note of the h prime s, that's what I say. Alright, take note of how this little stuff actually contributes to how you understand stuff. And that's why when you talk about first degree now, and we know that for h is a monic system, meaning its highest order for your h its coefficient is 1. Alright, therefore since its first order is just s plus h naught. Alright, as you can see, the denominator now is 1 order lesser than your numerator, and therefore is considered improper. And we can say that this is our equation for our transfer function for your controller, and therefore this is our fourth step. Okay, the next step is also something special, alright, totally different from what you have done. So please take note again, please be very careful of that. You're going to introduce your diverting, right? ACL. You know that ACL now is 2n, alright? So it's just n is equal to 2, so therefore it's equals to 4. Alright? So you're going to talk about 4th order of for your ACL. And therefore the equation for your diverting equation, you still remember, is A naught H plus B naught G, right? Is it? Correct. But however, still remember there is 1 over S now. So because you're talking about general equation, you're gonna somewhat bring this S over here already. Alright? So therefore we put this S over here as S A naught H plus B naught G. Alright? And also, because you're talking about H prime, if you still remember H prime, therefore you also need to put in your H prime over here. And these are the little things that you need to take note. Alright, be very, very careful. I just want to stress to you, and I'll spend more time. Take note, macam only. So please take note still. The S and this prime over here for improper system. Alright, because you always have a careless mistake. Alright. And therefore with that such of the case that happens, let's continue. The same thing, we just sub in our A naught over here. What is our A naught? Our A naught is simply where is it? S plus 1, S plus 3, right? A naught S is equals to this one. So when I sub in, what I have is this over here. Alright? And then H prime is simply this one over here. Your H prime S is simply this one. Alright, so I'll just simply sub it in. This is actually H0, sorry, H naught. And therefore what I have is S plus H naught. Okay? Plus, now is B naught G. B naught, what the hell is B naught? It's simply just 3. B naught is equals to 3. So it's just 3 times your G is simply your general equation over at your GS, which is this one over here. Alright, then if I were to just write it out, I will have thing over here. Ta-da! And this is my equation 1. Alright? It's still not very different, but except a little variations. That's why I just want to let you to take note of it, alright? And if you were to expand all this thing over here, because it's really hairy, you will have this long chunk over here. Okay? And therefore this is equation 1. And I highly suggest that if you're free, do it up. Alright? Because you can minimize your amount of carelessness when you do this thing. Alright? So now I gotta set up another equation for my ACL. So it's step 6. Alright? We know that our ACL is equals to 4. I mean your degree of order is 4. And therefore we will have 4 order. So our ACL will be something equals to some A, S plus A, S plus B, things like that. But we know that normally they like to write as S minus A, S minus B, S minus C, and S minus D. Alright, where your A, B are conjugates, if you still remember, minus, they are actually half 1 plus minus J, sorry, minus 1, and also 5 minus 1 plus minus J. Right. So if you split it out, you'll have half minus 1 plus J and half minus 1 minus J. So far so good. So this thing over here, you just sub in as your A, and this thing over here you just sub in as your b. Same thing for the 5 minus 1 plus minus j. Your conjugate will sub in for your c and your d. Same thing over here. Alright, I'm not going to go through with you, at least you get a feel of it right here, right now, which is pretty fresh for you. Alright, so if I were to do that, I have this thing over here. Okay, and you may wonder why I keep writing as half, alright, minus 1 plus minus j and 5 minus 1 plus minus j. I think this is some form of a gauge between the frequencies. But as you can see, it's in terms of a conjugate system, it's in terms of complex numbers. So you're dealing with some form of a frequency input. Right, when you talk about frequency input to control your controller, then you're going to talk about using these things. Alright, therefore, these are the little stuff that we don't know why is it like that, but at least you know how to sub in. Alright, so these are pure subbing in only. So ACR is equals to this thing, which is your equation 2. Alright, and if now you have to compare, alright, I'll just simply bring this equation 1. Yeah, let's compare now, alright, it's quite straightforward. So your 4 plus h naught is your 11s, right? Because it's in terms of the coefficient s cubed and s cubed over here. And therefore what I have is 4 plus h naught is equals to 11, and therefore h naught is equals to 7, because I bring this over to this side. 11 minus 4 is 7. Same thing I do for the rest of the G2 and G1. Alright, in the end you'll solve for your values, and therefore it's all over here. Your h naught is equals to 7, your G2 is equals to this one. Alright, and you take all this value and sub back into where we have just started, our equation, our general equation. So we just found out that our our h naught is equals to 7, so our h naught is over here 7. Where am I? Yeah, 7. And then the rest of the G naught, G1 over here is you can just take a look lah. It's already here lah. Alright. And things like that is over here now. Alright. But the last step, be careful. I almost forgot also when I see this now. Alright, is that you started off with a controller that is a integral. Alright, which is in terms of 1 over s gs plus h prime s. You're going to bring back your s over here again. Alright, therefore you haven't finished yet, so you're going to multiply another s, alright, over here, which is shown over here lah. And instead of c prime, you're going to change it back to c. Alright, and therefore you have to be very careful of all these little minor steps. This little minor steps are going to minus marks, so be very careful. Alright, so I think this is it for your integral inclusion of your integral actions for improper system. And just to take note that please take note of your criteria. Be very careful with this for the improper criteria. This is the thing that you need to take note of also. I shall see you soon.